productively. The last section is, how do we manage all this? How do we govern it? How do we set up markets for carbon to make sure that the transition in mining is happening as fast as it can? So with that, I'll pass it over to Vicki Lemieux.
Thanks very much, John, and pleasure to be here. So in answer to John's question, I'm going to give you a solution, and it's called blockchain and distributed ledger technology. And just in case you don't have a very clear idea of what blockchain and distributed ledger technology is, there's a lot of technical details, but basically it leverages both cryptography and decentralized architecture for technology to create secure and shared and often transparent ledgers. So that's the basic concept. And I established in about late 2016, so we're heading into our 5th anniversary, something called Blockchain at UBC, which is our blockchain research and education cluster. And we've now grown since then into a very multidisciplinary type organization. And this has been recognized by Canada's Information Technology Council that looks at how industries are evolving and how we're preparing our people for the future. And what makes blockchain at UBC unique is its multidisciplinarity, and it's something that the Academy is really thinking about, moving away from these strict disciplinary ivory tower hierarchies into much more problem-oriented types of research, as we've seen demonstrated already today in our seminar. So it's problem-oriented because that's where the impact can happen. So at Blockchain at UBC, we take a problem-oriented approach. And of course, when you're solving real-world problems, they don't neatly stack up into disciplinary silos. You have to have people working in teams across disciplines. So our disciplines include everything from computer science and engineering, which might be obvious choices for something like a technology, an emerging technology, but also business and various flavors of business, from management information systems to operations research to strategic business management to information science and archival science to law and various other disciplines that maybe touch some of our core verticals like medicine and public health, for example, Indigenous issues and so on. So we're quite a large and diverse group of people. And so if you've got a problem, we've got somebody there and a group of people that can help solve it if that problem suggests blockchain could be a potential avenue. So as I say, we founded about 5 years ago, and we've grown since then into this multidisciplinary team. We have a very community-based ethos. I think that also is what sets us apart. So it's not about students coming in and learning in the classroom. It really is about co-generation of knowledge between faculty, students, and most importantly, when we're working on problems with impact on society, our industry partners. So we've got about 30 or 40 different industry partners, some of them quite large in their sectors, some of them quite small, startup type industry partners. But we're engaging with all of these types of different industry partners, and the students do internships with those partners, which I'll come into a little bit more to discuss in more detail in a moment. But we were very fortunate last year to receive an ecosystem award for this unique multidisciplinary community that we've set up around blockchain technology. So here's just to give you just a smattering, a sampling of the kinds of projects and industry partners we have, and the types of students or trainees that we have working on them, the level of funding. Some of them are quite small, some of them are larger scale. Here's one that is funding a postdoctoral research fellow and some PhD and master's students with a global pharmaceutical company. and looking at the application of blockchain in the clinical trial process. So although we focus on some verticals like healthcare, for example, what you find is that a lot of the supply chain management issues, for example, a lot of the needing sensor data to be broadcast in a secure fashion, a lot of these issues are transferable across different domains. So we have the advantage also of being able to learn from the application areas in these different domains to apply these technologies in novel ways across different industry sectors. Again, with Boehringer and Ingelheim, here's the theme. We do find that once we engage with an industry partner, they come back. We have repeat business. They come back for more. They find our engagement quite helpful. So here's another one where we started to look at blockchain's consensus mechanisms and so on. Another one of our industry partners in healthcare is Molecular U, looking at precision health management. And this one was co-financed by Canada's digital technology Supercluster, which I'll have a little bit more to say about as a potential source of funding. And you can see, you know, the vast number of students. Some of those are PhD students, some of those are master's students, some in information science, some in engineering, some in psychology. Who else have we got? Business. So they're very, very diverse, and they're all contributing to different facets of solving the problem here. Again, with Molecular U, they've come back now and they're funding a postdoc who is looking at consensus mechanisms for their blockchain solution. Continuing on, Finhaven is in the decentralized finance space. So these are a couple of master's students. A lot of these have the same topic, the theory of blockchain as a socio-informational technical system. We tend to look at the design of blockchain solutions through this three-dimensional or three-layer approach, as we call it, which lends itself to multidisciplinarity, but also lends itself to thinking about some of the social issues, social impact issues that might be important in the design of blockchain solutions, the informational aspects such as data structures, who will own the data, you know, how's data moving across international boundaries, what are the compliance issues associated with that, and then of course, you know, naturally the technical components of the system. And so this particular project we actually put together as a consortium effort by these different industry partners. So it doesn't have to necessarily be done as a separate project. It can be a bundling together, a consortium of different industry partners that come together to put in a holistic application, which is the case here with our DeFi partner Finhaven, British Columbia's Land Title Office, Fortis, Peer Social, which is a decentralized social media, Aquanow, also decentralized finance. And finally, we've got another partner that's just new, working on healthcare and decentralized healthcare solutions in opioid management. So how do these partnerships normally work? Well, we leverage something called MyTax, which is a funding agency that has been provided funding through the federal government. And how it works is there, with each intern student, for example, the industry partner contributes Canadian 7,500, and the federal government matches that to bring the total of funding up to 15,000. Now, for larger groupings, the leverage can be even better than that for the industry partner. And I'll talk about how the expense of that can be offset. You know, the industry partner 7,500 can also even be offset further. And this yields for the intern a $10,000 worth of funding, which helps with their research and going to school, and an additional 5,000 of what we call fungible funding to support travel as part of the research or equipment that might be needed. And for the research partner, though, you have access to a master's or PhD student who is working full-time on a research problem for you between 4 and 6 months in length. And then, you know, that can be extended and you can pull together entire teams. So it really is, it's been a very successful funding model for us. It's worked very well. And the only requirement is that the company have a Canadian footprint, which means you might have a branch office here, or you might have a subsidiary here. And that's the only requirement. So it's really a good facility. The next one I wanted to mention is the Digital Technology Supercluster. So at the moment, they're just working out, there's been a new federal budget and they're just working out what funding will be available through this facility. But it has funded projects, you know, over $1 million, sometimes multi-millions of dollars. And what they do is they help smaller industry partners pair up with larger industry partners that are part of this technology supercluster consortium. So you would become a member of the consortium, and then you would be able to access the funding, and they would, you know, partner you up with smaller scale industry partners or larger, depending on you know where you're coming from, to create a strong consortium for the commercialization of some technology. And then the Canadian government co-invests and provides you know, guidance and around commercialization and so on of the technology. So this can also be a really useful facility, and it could allow you, if you're bringing in MyTax students, to further leverage your funding, because you are eligible to be reimbursed through this technology supercluster for the money that you're spending on developing your technology. So another opportunity to receive reimbursement on some of the initial 7,500 is through Canada's National Research Centre Industrial Research Assistance Program, especially for youth employment. So if you have someone who's, I think it's aged 15 to 30, there's quite a large age grouping there who is working on developing novel technology with you, you can actually apply to have a portion of their salary reimbursed. So that would include the 7,500 investment. So again, this can be another way to leverage that investment to really scale up the talent, give young people opportunities, and get yourself a very flexible talent pool. Finally, one of the larger initiatives is the Strategic Innovation Fund. This is for larger scale, you know, in the millions of dollars partnerships. So it's really around creating networks. So if you know, companies here through say BRIMM could convene a consortium of industry partners that are interested in working on a particular problem collectively, and this would be the kind of fund that could be accessed to achieve that kind of objective. So blockchain at UBC is, you know, actively lots of MyTax students, active digital supercluster projects. We've yet to do active IRAP reimbursements with our industry partners. We've yet to do a strategic innovation fund because that's new just this year. So my invitation to you would be, well, let's get together and make this a first around some of the issues that might be interesting for us to explore. But that's basically blockchain at UBC. And so I'm going to turn it back to John now, and you know, if there's questions that come later about what I've presented, I'm happy to respond.
Thank you very much, Vicki. And we'll get questions through in the chat. But as you say, there's an incredible number of different schemes to assist the financial costs of industry partnering with universities. You might guess that from my accent, I'm not Canadian, but Canada is just, for research funding, it really is pretty good. So I would encourage you to have a look at these things. There are so many different schemes. It's just a question of finding the right match to the right scheme for the right strategy. But that's what we're here for. We're part of those conversations. Blockchain is a newer area for BRIMM to look at, and as you can tell, this is an area that we're exploring. You know, other areas like Greg Dipples and Alleys have been around for quite a long time, but we're very excited about blockchain. So I'll just ask Harish Krishnan to explain some of the ways that we're thinking about this, and then I'll hand it over to Greg Leach as our newest industry partner for a case study.
Great, thank you. So everybody see my screen and can hear me okay?
We are all good, thank you.
Perfect, thank you. So my name is Harish Krishnan. I'm a faculty member at UBC's Sauder School of Business. And as Vicki said, blockchain at UBC has really been quite instrumental in sort of bringing people across campus together. And so I connected with Vicki and blockchain at UBC because of my interest in supply chain transparency. So here we're talking about supply chain transparency and tracing the carbon footprint of in mining supply chains or other kinds of metrics, ESG metrics. But really, this is sort of a broader issue that shows up in many different industries and many different contexts. So this is not just a challenge in mining, of course. So, if you look at, the food supply chain, there is a need, a real business need to sort of be able to trace the provenance of food as it moves from fields and farms all the way to the end consumer, and it goes through various stages of processing. Maybe not unlike a mineral supply chain. The apparel industry has similar problems where they need to trace the conditions, working conditions, and maybe an upstream factory somewhere. Again, kinds of problems that you see in other settings, including in mining. And another example is of supply chain transparency, or the business need for supply chain transparency is from the airline industry. And in this industry, aircraft have millions of parts. Many of them are rotable parts, meaning they come off the aircraft and they get maintained and refurbished and then go back into aircraft. And in order for this to happen by regulation, you need to maintain like a history of a part from the time that it was produced through all the different stages of use, all the different aircraft it went into, and so on. And this tends to be, all of these records are paper-based, and you can imagine sort of the inefficiencies that might arise if you lose paper records. Then $1 million part is just basically a big paperweight. And so basically there are all of these settings where supply chain transparency is important, and we need to sort of capture information and be able to share it internally and externally within our supply chain and with regulators and so on. And so this is a problem that is something that I've been interested in some of these different settings, but certainly mining seems to be one area where the opportunities are really immense. And technologies like blockchain hold some promise, but this is not just a technological problem, right? Rather, this is really a problem where to achieve transparency, to transform supply chains to be sort of transparency driven, you need to solve a number of sort of interlinked problems. And the technical problem is one, but then there is the problem of how you collaborate with your ecosystem partners, and then there's a problem of information. What kind of data needs to be captured, what's available, what new data needs to be captured to achieve transparency, and so on. And so what we've been interested in, there's a group of us at UBC who've gotten together to sort of work on these problems. And what we're really interested in is sort of, how can we sort of help industries make this sort of transparency-driven transformation of their supply chains. And so I like the word transparency-driven because it's not just a digital transformation where we digitize existing, data and information, but rather we think very intentionally about what is required to achieve greater transparency, what kind of information is needed. Also, putting the word transparency-driven, I think, also helps to bring together ecosystem partners, because if everybody understands what we are doing, which is to enhance transparency across the supply chain, there is a greater sort of possibility of collaboration. So what I want to do in the few minutes that I have is to tell you a little bit about how we've been thinking about addressing these interlinked challenges. So these are, of course, challenges that many industries, many organizations are trying to address. So what can we bring to the table? And so about a year ago, we put together a very large grant proposal to work on this problem. And that was a competitive and large proposal, which did not get funded, but putting that proposal together allowed us to do a couple of things. So we were able to bring together a group of faculty from across UBC who are interested in this problem. And it also helped us sort of clarify the questions that we need to address to sort of move forward with this research agenda. And so I thought I would share this with you in the hope that this generates some interest, as Vicki and John have mentioned, and hopefully we can partner with people who are interested in sort of implementing these kinds of solutions. So what the proposal sort of identified is, the skills or the research strengths are sort of scattered across campus. People are working on sort of aspects of this problem. But what really the interesting problems are at sort of these intersections of these different areas. So if you look at, the intersection between sort of the informational and the social component, the question is what data and what metadata is maybe required, and how can this be captured and shared with different stakeholders? So the statement of this problem sounds simple, but this is obviously a very challenging issue to deal with. The practical challenges are significant. So, for example, data is siloed across different ERP systems across the supply chain. Data may not be in digital form; it may be paper-based, like I've mentioned, and some data may not be available, and new data may need to be captured to address the needs of transparency. So that's one set of questions that we would need to address. The second set are at the intersection of the technical and the informational components. So here, this is really around, what information. Again, this is a sort of a simple statement, but a fairly challenging problem. So questions like, what information do we capture? What needs to be stored on the blockchain? What needs to be stored off-chain? How can the system scale appropriately as in a large supply chain, and so on? And the third set of questions is at the intersection of the social and the technical components. So how will ecosystem partners interact with the technical components? What are the user interfaces, the tools, the processes that are needed to facilitate and accommodate the needs of our ecosystem partners? So for example, how can regulators be convinced to move from maybe existing paper-based records to something more digital? And of course, these are just a preliminary set of questions. There'll be other questions that come up. This kind of transparency-driven transformation creates other opportunities as well. So regulation might move from sort of an after-the-fact audit to something more proactive and preventive, for example. But so in conclusion, what I really wanted to leave you with is the thinking that we've put into this problem around how we can achieve this transparency-driven transformation. There are many advances going on in parallel, but really our ambition, our goal is to try and bring all of these components together so that we can create a working system for tracking and reporting ESG. And we certainly see mining as a great application area for this. And so we'd be very interested in collaborating with partners to make this a reality. So that's really all I had. I'll hand it back to John.
Thank you very much, Harish. And I mentioned there that we've had some interesting discussions with the provincial government, who are very interested in blockchain and mining and reporting. So certainly a technology which is finding a lot of interest at the moment. I'll now invite Greg Leach, who's the CEO of Blockhead Technologies. Blockhead is a Canadian-Australian company, works with a lot of the mining companies that are part of the BRIMM network. And this is how we found about Blockhead Technologies. It was actually a conversation with a vice president over a beer, and when we used to do these things. And certainly we've had some great conversations with Greg and his team. So I'd like to get Greg to give an example of some cases that he's working on at the moment.
Okay, thanks, John. Can everyone hear me okay?
Yep, you could hear and see you fine. Thank you.
Oh, great. Okay, so yeah, I'm Greg Leach. I'm the CEO of Blockhead Technologies based in Perth, Western Australia. A bit of background on Blockhead. We're an Australian-based organisation. As John said, we develop blockchain-enabled apps for the mining sector. And what I'm going to do in this presentation is just give you a couple of real-life examples of what we've built that are actually being utilised today. So Blockhead's core focus is on driving operational efficiency, supply chain management, and ESG measurement and reporting. Our proprietary platform is called STAMP, which stands for Smart Tracking Asset Management Platform. It's a data and analytics platform that drives operational performance, digitises supply chains, and measures and delivers on ESG objectives. When we talk to our clients, they generally have similar issues and objectives, regardless of the size of the client. They all want to maximise productivity and shareholder value. They're all focused on empowering sustainable change, which underpins their ESG objectives, and they always want to reduce costs. Transparency with stakeholders and shareholders is important, as well as protecting and also strengthening their brands. So to help our clients achieve these goals, we've developed 4 apps at this stage on the STAMP platform, which you can see on the left of the diagram here. The first one is Stamp Fuel, which is targeted at diesel fuel management. Second one, Stampvision, which is an image-based digital fingerprint solution for precious metals. Then we have Stamp PSTG, which is our ESG performance measurement and reporting module. And finally, Stamp Supply, which is traditional supply chain visualization and tracking using blockchain. So what are some of the major focus points we see in the mining sector at the moment? Well, firstly, ESG compliance is stronger than it's ever been across all aspects of mining operations. We see a particular focus at the moment on proof of authenticity, carbon footprint reduction, and of course, supply chain provenance. So many mining companies have fragmented supply chains with many stakeholders across multiple geographies and logistics processes. They are often opaque and the granular details are not very well understood. So blockchain, combined with other technologies, enables tracking and extended visibility over all facets of a value chain. What this does, it gives consumers evidence and transparency over product origins. Additionally, mining companies are also focused on simplifying and lowering the cost of compliance. This includes approvals, permitting, reporting across a myriad of activities, including ESG, as well as financial compliance and reporting. So using blockchain and smart contracts improves transparency, the auditability and security of these activities, and therefore reduces compliance effort and costs. So I'll quickly move on to the first part of the presentation, which is focused primarily on an example in ESG and our Stamp Fuel and Stamp ESG modules. So as I've previously mentioned, mining companies are focusing on ESG more than ever before. This is largely due to shifting consumer demand and more stringent regulatory requirements. So they're going beyond basic compliance requirements and setting more ambitious stretch targets, and they're introducing new innovative solutions to achieve them. So the key feedback we get from our clients is that all the change must be sustainable, obviously. They must remain profitable and deliver returns to shareholders. They want the ability to set and measure and report on ESG targets in a transparent and secure manner. So a major focus that we currently see in the sector is the measurement and reduction of an operation's carbon footprint. So one of the most significant contributors to carbon footprint for many operations is diesel fuel consumption, which is where Stamp Fuel comes in. So I'll now talk briefly about what Stamp Fuel is. So it's basically a solution that provides organisations with a comprehensive understanding of their entire fuel ecosystem, and there's many benefits to this. So it enables organisations to reduce their fuel consumption and therefore their carbon footprint. It identifies fuel loss, and this is primarily through theft, which immediately reduces overall consumption and greenhouse gas emissions. And to give some context there, like globally, there's over $100 billion US of diesel fuel that goes missing each year. It automates diesel rebate calculations for vehicle use on non-gazetted roads. And importantly, through blockchain, it provides an immutable record of each claim for assessment by the relevant authorities. This is a real highlight of the product. So once Stamp's fuel has been operational for 3 months, it actually starts to identify opportunities to reduce consumption through environmental changes. So these environmental changes will result in an improved bottom line and obviously contribute to the achievement of the carbon reduction targets. So an example of an environmental change may be a recommendation to reduce a road gradient. Look, while this might take significant capital expenditure, Stamp Fuel will tell you, based on the current data, how long it will take for you to get a return on investment for that change, the reduction in fuel consumption, and a reduction in an operations carbon footprint. A quick introduction to Stamp ESG. So this is the first iteration of Stamp ESG, and it's an integrated ESG carbon footprint calculation and reporting module. Basically what it does, it calculates and reports on an operations carbon footprint that is a direct result of diesel fuel and power usage. So it enables mining companies to track their progress against reduction targets more granularly and measure the effectiveness of improvement initiatives almost immediately. These results can obviously be integrated into deliverables such as life cycle analysis and also help inform decision making on capital expenditure. Finally, Stamp ESG, like our entire product suite, uses a combination of methodologies such as custom heuristics and machine learning that enable Stamp to learn from your data over time and improve its accuracy. So the second example of blockchain in mining, I'm going to talk about the precious metals traceability and tampering detection product called Stampvision that we are developing or have developed in conjunction with ABC Refinery in Australia. So let's start with the challenges of gold supply chain tracking. So whilst it's changing, up until recently, out of sight, out of mind has to a large extent been the business as usual approach for gold supply chains. They're typically closed in nature, and supply chains that carry these metals from the source to the final destination have supported this approach. However, as we all know, consumers, investors and shareholders are now demanding increased transparency across these supply chains. They want to know what they're buying, where it came from, and the impact the potential purchase is having on people and the planet. So I'll just touch quickly on ABC Refinery. So they're a division of Pallion Group, which is Australasia's largest independent precious metals services group. Based in Sydney, New South Wales, they currently refine over 4 million ounces of gold annually, 400 tonnes of silver, and have a turnover of in excess of $10 billion Australian. ABC have recently invested in technology in the refinery, and they're the only environmentally sustainable refiner in Australia. So what this has led to is they've actually created the environmentally friendly green gold concept, and gold buyers from all over the world look to purchase ABC bullion for this reason, and they often pay a premium for that. So due to widespread counterfeiting, the gold sector is now facing far greater scrutiny, and consumers are seeking verification on the quality, ethical and sustainable origins of the products that they are purchasing. So what ABC wanted is they required a solution that the consumers can use to prove that the bullion they have purchased is actually authentic ABC bullion, and therefore it's environmentally sustainable, and also that confirm that it has not been tampered with post-refining. So an example of gold tampering, especially like typically on 1 kilo bars, is that they get drilled out and the gold taken out of them, and that's replaced with tungsten, which is the same specific gravity as gold, same weight. And often you can't detect this with the naked eye, and it's obviously can be a very expensive issue. So Blockhead with ABC we've created Stampvision, which is a software as a service gold tracking, authentication and tampering detection solution. Has the following objectives and capabilities. It uniquely identifies each bullion bar using its intrinsic properties. Now this is done by taking images as each piece of bullion comes off the conveyor belt, in conjunction with the serial number and other data. It authenticates the bullion is actually from ABC Refinery, and therefore it is ethically and sustainably sourced. It actually automatically detects if the bullion has been tampered with, and it does this. It allows the consumers of ABC bullion at any time when it gets bought and sold post refining to use a mobile phone app to verify that it is authentic ABC, and secondly, whether or not it's been tampered with. The solution not only works with refined bullion, but also doré. So the next part of the project is to track doré from the mining company to the refining operation. So both of these applications are fully blockchain backed, like it's perfect for these types of applications. So obviously the gold fingerprint's written to the blockchain, it's fully secure and immutable, and it's just a really good example of where blockchain can apply to the sector. I'll just finish off just quickly with how it works. I've already touched on this, but yeah, so we've implemented IoT sensors and cameras at the refinery, and they record images that comes off as each piece of bullion comes off the conveyor. Our machine learning system captures the intrinsic properties of each bar, which is converted into a fingerprint along with other relevant data. This is stored on the blockchain using our IP, which is known as Blockhead. Once this is complete and the bullion enters the consumer market, then as I said, the consumers can verify that bullion is authentic and hasn't been tampered with. So far, we're just commercialising at the moment. It's just being deployed in Australia before it gets deployed globally. And yeah, again, it's a really good example of where you can apply blockchain into the mining and precious metals sector. And that wraps it up from me. Thank you.
Thank you very much, Greg. I think this is one of the most, it's a very exciting technology and what it can enable the industry to do. So we're very pleased to start this work on blockchain with BRIMM and connect with industry, and technology players like yourselves, but also blockchain at UBC. So thank you very much. And also it's 6 a.m. in Perth, so thank you particularly for being up at this hour of the morning. Thanks,
no worries.
Greg. Okay, well that brings us to the end of our webinar, and I just want to conclude by thanking all of the speakers. Thank you to all of you who've come along today. The support has been tremendous. I just want to mention that these are active research projects. We're looking for ideas, industry partnerships, and reach out to us. You know, we have a website that's quite active. It's brim.ubc.ca. We update it regularly. You can post a contact in there, or you can contact me or others through LinkedIn, or email info@brim.ubc.ca. And we'd really like to talk to you. The way we work is we sit down and we discuss what the issue is, and we try to find the best people to connect. So thanks to everyone, and we look forward to talking with you. We have a white paper that's been the result of the research leading up to this, and we'll release that and let you know where you can be downloaded. Thank you, everyone.
Thanks, everyone.